In this video, we are going to begin to look at logarithmic functions. You need to have the logarithmic functions worksheet in front of you that is posted in the class folder for today. So, having said that, let's go ahead and get going. We have been looking at functions of the form y equals a to the x. The logarithm is a new type of operation we are defining that is the inverse of the exponential function. If y equals a to the x, then logarithm base a y equals x. So the logarithm undoes the exponent. We can use an idea that I call the logy-froggy. The logy-froggy, which helps us transform from one form into the other. It says that a to the x power equals y. And it looks like Kermit the Frog. All right? A to the x power equals y. So this is called the logarithm. And in order to work with a logarithm, you must have a base. Notice that the exponent from the original exponential function ends up being the standalone term on the opposite side of the equality sign, and the y has moved into the functional value of the logarithm. One of the keys is to remember to think of the logarithm as the inverse of the exponential function. So remember, logarithm is the inverse of the exponential. So if we think about it like that, that tells us some information about logarithmic functions right off the bat. Here we have the information from our last section about exponential functions. If the logarithm is the inverse of that, so f inverse of x equals log, oops, let me grab my other pen, like thinner one, equals log base a x. So when we talk about inverse functions, remember that the domain of the original function is the range of the inverse and vice versa. So in this case, the domain, since the range of our exponential function is 0 to infinity, the domain will be 0 to infinity for the logarithmic function. The range, since the original function had a domain of all real numbers, the range of my inverse is all real numbers. The x-intercept, since I had a y-intercept of 1, 0, I will have an x-intercept of, since I had an x-intercept of 0, 1, a y-intercept of 0, 1, I now have an x-intercept of 1, 0. Since I had no x-intercept, now I have no y-intercept. I will have a vertical asymptote at x equals 0, and there will be no horizontal asymptotes. Because they are inverse functions, they have graphs, and the information about them is just like it would be with any other set of inverse functions. F of x equals a to the x. Here is the graph of what an exponential function looks like. Remember that we had two important points on this graph. We have the point 0, 1 and the point 1a. when we initially studied the idea of an inverse function, we said that inverse functions are symmetric about the line y equals x. So if this is our exponential function, our logarithmic function should have a asymptotes opposite here. So this is asymptotic to the x. Our logarithmic function will be asymptotic to the y as it goes negative. I had the point 0, 1. I have the point 1, 0. I had the point 1a. Now I've got the point a1. And notice this looks just like that does, only mirrored about that line y equals x. Logarithms can have a base just like exponential functions' base. In other words, the base, that a value, is any number that is greater than 0. But there are certain bases that we use more often than others. The first is called the common logarithm. The common logarithmic function is the logarithmic function that has a base of 10. So f of x equals log base 10x. You will never see this. What you will see is f of x equals log x. If there is not a number listed as the base of the logarithm, then it is assumed that the base of that particular logarithm is 10. So you will never see a problem that has a base 10 in the logarithm. If there is no base listed, then the base of that logarithm is 10. In our last class, we encountered a new number that we referred to as e when we were working with special cases of exponential functions. E is called the natural number, and the natural number has what's called a natural logarithmic function to go on with it, to go along with it. F of x equals log base ex. You will never, ever, ever see log base ex. The equivalent statement would be f of x equals ln x. All right, so this is a lowercase l followed by an n. You are taking the natural logarithm of x. So this is called the natural logarithmic function. So whenever you see that ln, you know that you are working with a base of e. And we will talk about that over the next couple of videos. Your calculator has several different keys that are going to be useful when we work with logarithms. You'll notice on the left side of the screen there are buttons that say log, and there's a button that says ln. So if I wanted to take the log of 1,000, now the log of 1,000, 10 to what power gives you 1,000? That's what the logarithm tells you. So 10 to what power gives you 1,000? I hope that all of you are sitting at home right now saying 3 out loud over and over again, because log 1,000 is 3. So what that basically says is, and again I'm going to put that 10 there even though you won't normally see it, just so that we can see what's happening here. That tells us that 10 to the third power equals 1,000. So 10 to the third power equals 1,000 is equivalent to log base 10 1,000 equals 3. The other logarithmic key that we have access to is the natural logarithm. So you have ln 5, and it gives us some decimal number. But what that means is that e to the 1.609 equals 5. Because e to what power gives us 5? E to the 1.609 power gives us 5. If you have a newer TI calculator, then you can at this point also hit Math, arrow down till you get to, let's see, log base, which is the letter A. Hit Enter, and now you can put in any logarithmic base that you want. So log base 5 625 is 4 because 5 to the fourth power equals 625. If you have an older calculator like a TI-83, there is a way to do that. It's called the change of base formula, and it is something that we will talk about in the next video. But that should get you started with logarithms. There will be at least one more video posted for this evening's assignments. Happy logarithming. I will talk to you soon.